So we know that the way that we figure that out is just count the decimal 1, 2, 3, 4, 5, 6. So, and since we're moving it in towards this direction, we know that that will be negative, since that number is smaller than 1. So the correct answer is B. Piece cake? You're like, man, I wish they all were like this, right? Oh, sig figs. Yes, love this, right? Which of the following numbers contain the designated correct number of significant figures? This one says 5. This one says 2. This says 3. This says 2. This says 4. Only one of them is correct. So, how many of you guys say A? Raise your hand. Okay, so we have no A's. So we know that one's wrong. What about B's? If I say B, well, we know that one's wrong. How about C? I have 1, 2, 3, 4. We have 4. 4 for C. C is the correct answer. All right. The way that we know that is because these are placeholder zeros, right? They're just holding the place since there's not a decimal here. So that means that only these first 3 numbers, since they're real numbers, non-zero numbers, they count as significance. This guy would be 3 because there's the 0 in between, counts as a significant figure because it's between. This guy would be 5 because we took the extra time to put that extra 0 there after that decimal point. So since we have that decimal point and we have that 0 following it, that's extra work. So we know that this guy should have been 5. Okay. Does that make sense? I wouldn't spend too much time on sig figs. I mean, it helps, but if I remember the test correctly, there's only one question, if that deals with it. So, okay. So which of the answers for the following conversions contain the correct number of significant figures? How many of you guys think it's A? Nobody? Okay, it's not A, because this one has 1, 2, 3, 4 sig figs. When we know that we're doing multiplication and division, we always go with the one that has the smallest number of sig figs. There's 1 sig fig here. So this should be 1, right? Ooh, but there are rules. Let me elaborate on those rules. So we know that if it's numbers that are used in conversions, like for instance, this is used in conversions, then we're going to use what we're starting out with. So the conversions don't count towards sig figs. Okay. So what about here? We have 2 liters times 1.06 quarts over liter. Is that the correct answer? 3 sig figs? No, it's not that one either. So yeah. What about this one? We have 4 sig figs here. This here is a conversion, and we have 4 sig figs here. Yes, no, maybe? You think so? So we have 2 that say possibly this one, right? Anybody else going to agree? I have another nod. Okay, well, so what about this one? This one has how many sig figs? Are you sure? 3 sig figs, because we took the time to put that 0 after the decimal point. Anytime that you have a decimal point and you take extra time to put a 0, right, that means it's going to be significant. Okay, so then this has how many sig figs? This has 2. There's no decimal point here, right? So this one is just a placeholder. So there's only 2 sig figs. So then we know that this one is incorrect. And then this guy has how many sig figs? 3 sig figs. And then this has how many sig figs? 2. So we know that this one is incorrect. So the correct answer is C. Doesn't it feel good to be good? I mean, right? Okay, number 4. Which of the following measurements are not equivalent? We have 25 milligrams equals 0.025 grams. We have 183 liters is equal to 0.183 kiloliters. We have, C, 150 milliseconds is equal to 0.15 seconds. Then we have 84 centimeters is equal to 8.4 millimeters. And then we have 24 deciliters is equal to 2.4 liters. Okay. You said B? D as in donkey? Okay. And so why do you say it's D? Yeah, why do you think it's D? Oh, I'm sorry. I'm pressing E, right? Sorry. Yes. So we know a centimeter, centa, and milli. So we know milliliter or millimeter is smaller than a centimeter. So for every 1 centimeters, that should equal 10 millimeters. We actually have this one reversed. So the correct answer is D. Okay. God, I wish they're all this easy. Which of the following setups would convert centimeters to feet? A, B, C, D, or E? So let's look at A. A work? Okay, why not? Okay. So these guys are inverted. So for every 1 inch, we know that that's 2.54 centimeters. Okay. What about this one? No, because we'd end up with centimeters squared over feet. Right? So we know that that's wrong. Okay. What about this one? As I'll say it's C. C is the correct answer. You know that this one was wrong because we'd end up with inches squared over feet. And we know that this one is wrong because again, the inches, the conversion is wrong. So yeah, actually it is exactly the same as A. I've done questions like that. I used to repeat questions on exams because I gave me an idea of whether a student was guessing or if they knew the material. Okay, so a doctor orders a 0.125 gram of ampicillin. The liquid suspension on hand contains 250 milligrams per milliliter. How many milliliters of the suspension are required? So what should we start off with? Zero point 125 grams. And this is milligrams. So how do we change from grams to milligrams? That is correct. 1 gram is equal to 1,000 milligrams. Okay. And then 250 milligrams on the bottom. And I assume 5 milliliters on top. Got 2.5. Okay, questions? Pretty straightforward, right? Okay, so a nugget of gold with a mass of 521 grams is added to 50 mils of water. The water level rises to 77.0 milliliters. What is the density of the gold? Okay. So we go 77 minus 50 equals 27 milliliters. And then you said just divide 521 by 27. So what they typically like to do is they'll give you a graduated cylinder that has a volume initially starting out, and then they'll show another graduated cylinder that's moved over, saying that it moved up. What did you guys get for the value? 6.77. You got 19 point what? 19.3. Okay. So 521 divided by 27. Okay, so we're not going to listen to Sergio anymore, giving us the wrong answer. After he tells us how to do it, right? Call his own directions. Okay. So which of the following substances will float in gasoline, which has a density of 0.66 grams per milliliter? You guys agree with him? This is B, possibly. Don't know. Don't know. Which one is lighter density? Yeah, the one that has the lighter density is always going to be the one that's going to float, right? So, for instance, oil and water. Oil has a density of 1.00. Water has a density of 1.00. Oil has a density of, I think it's 0.97, well, depending on the oil that you wear. But it's like 0.97. So which one's going to float on top of the oil? Or a balloon on top of water. Is the balloon going to go to the bottom? Or it's going to sit on top because it's less dense. So they ask a lot of questions that are like that. They're kind of big picture questions. Like, I'll give you another example real quick. I know I'm jumping off the thing, but so what would be the best depiction of an element? Type that out. Their drawings are better than that, but not too much better. Leave my artistic talents alone. These guys all look alike, don't they? These guys all look alike, don't they? Sort of. These three look alike, but these three don't look alike. And then these guys all look alike. What is the definition of an element? Is it the same atoms joined together? Do we have any elements that are like this? If each one of those circles represents an atom, we don't have any elements that are like that. What do you guys breathe? What was that? No, what are you supposed to be breathing? I know we breathe in air, but what is it in the air that you oxygen? Okay, what is the chemical formula for oxygen? Oh my God, O2, right? So that means two of the elements that looks exactly the same. Oh my God, this could be oxygen, right? Two of the elements that look exactly the same, right? So that would be an example of a diatomic element. So the best depiction of an element is A. Where this one is, these are one atom, two atoms that are exactly the same, right? So this would be an example of like water, yeah. And then this would be a mixture, right? So if they ask you which one depicts a mixture, A, B, or C? Okay, so those are the questions that they also have on there. And then, you guys know it, right? Because O2 is an element, right? But you guys, the first thing that you guys do is like, you get hung up on my artistic work, rather than looking at the big picture. Okay. So match the type of measurement to the given units, options A through E. So number 9. What do you think that one is? Is it A, B, C, D, or E? You guys agree with him? Okay. Number 10. Okay. Number 11. Number 12. D. Number 13. Right, C. And number 14. Piece cake? Like, damn, I hope they're like this, right? That's what I'm thinking. Like, man, I hope my test gets, why were mine this easy? I don't remember that. If they put density in there, it would be mass over volume, which is grams per milliliter, or kilograms per liter, right? Okay. Okay, for questions number 15 through 22, select the correct prefix to complete the equality. One gram is equal to blank kilograms. Yeah. I'm assuming. So you're saying G? So it's 0.001, because we know that 1,000 grams is equal to a kilogram. So it's G. I'll put the letters into my handwriting. Right, Sergio? My handwriting. Okay. 1 meter is equal to blank millimeters. You guys agree? Correct answer is 1,000. One centimeter is equal to blank millimeters. Thousand, because we know that the answer is 10. A centimeter is 1 centimeter, or 100 centimeters, is equal to 1 meter. And 1,000 millimeters is equal to 1 meter. So that means that 100 centimeters will equal 1,000 meters. Or we could just say 1 centimeter is equal to 10 millimeters. Okay. 1 deciliter is equal to blank millimeters. What is a decade? 10. So we know that a deciliter is going to equal to 10. So 10 deciliters will equal 1 liter. Right? And we know that a milliliter is going to equal how many meters? I mean, and liters. 1,000 So then 1 deciliter is going to equal 100 milliliters. So the correct answer is F, 100. Okay. So 1 kilogram is equal to how many grams? 1,000. A picogram is equal to how many grams? So the way I always remember it is, I know a nanogram, nano starts with the N and 9 starts with N. So 10 to the 9th nanograms will equal 1 gram. And I know a pico is higher than that. That's usually what most people go up to, picograms. Sometimes they'll go to a femto, but pico means 12. So 12 picograms will equal 1 gram. So then if I have 1 gram, that's going to equal, if I have 1 picogram, that's going to be 5. 1 times 10 to the minus 12. So this one is 10 to the minus 12. And then 1 gram equals 10 to the 12 picograms. And then 1 milliliter equals to how many cubic centimeters? Talked about this in class. It's a 1-to-1 ratio. Yes. So 1 centimeter is equal to, 1 milliliter is equal to 1 cubic centimeter. CC stat, right? That's what I always remember, because that's the syringe. You guys think about the syringe, and the doctor's going to shoot you up with the syringe. He's not going to shoot you up with a big syringe, right? You don't see anything like this, so they're probably comparable of it. If you looked on one side, it's always milliliters. On the other side, it's cc's. So they're the same 1-to-1 ratio. Chapter 2, energy and matter. Energy matters. When a solid is converted directly into a gas, the change of the state is called, we talked about this, right? A, freezing. If you're going from a solid to a gas, it's not called freezing. B, melting. When we're going from a solid to a gas, that's called melting. C, boiling. We're going from a solid to a gas. Is that called boiling? No. D, condensation. No, because think about condensation. Like you think about your glass of water and the water that's sitting on the outside of it, that's condensation, right? Okay. So then by default, it has to be sublimation. Dry ice. Remember we talked about dry ice last week. Okay, so in a gas, the distance between the particle is A, very close relative to the size of the molecule, B, close relative to the size of the molecule, C, fixed relative to the size of a molecule, D, small relative to the size of the molecule, or E, large relative to the size of the molecule. It's a gas, right? So the distance between a gas molecule and another gas molecule is always pretty wide, right? So let's say, for instance, if Sergio farted, right? The gas doesn't just sit right there next to Sergio, right? It expands out, it moves, right? So it's going to be further distance, it's going to diffuse. Yes. So the correct answer is E. Okay, helium is a or an compound, a heterogeneous mixture, an element, a homogeneous mixture, or an electron. Piece of cake, right? Like, when are they going to get hard, right? Air is a compound, a heterogeneous mixture, an element, a homogeneous mixture. E, none of the above. You guys agree? What does homogeneous mean? Homo. What does homo mean? The same. Hetero means different, right? So doesn't it all look the same? Does air look any different? I mean, I guess if you're in like the Bay Area or something like that, where there's a lot of smog, or LA. So the correct answer is homogeneous mixture. Which of the following is a chemical change? A, cutting a rope. B, bending a steel rod. C, making a snowman. D, burning sugar. E, melting gold. Did you guys say D or B? D as in donkey? Okay, good. Correct answer is D. Which of the following is a physical change? A, baking a cake. B, dry ice subliming. C, fermenting grape to produce wine. D, digesting food or digesting a meal. E, a tomato ripening. What did you say? The correct answer is B, right? Because we're going from dry ice, which is carbon dioxide, to carbon dioxide gas, right? So that's a physical change. Okay. 29. How many calories are required to raise the temperature of a 150-gram sample of gold from 25 degrees Celsius to 75 degrees Celsius? The specific heat of gold is 0.0308 calories per gram Celsius. And to give you guys a hint to this, right? Anytime that you have like questions like this, look at the units. So the units will tell you how to do it, right? So the specific heat is calories per gram Celsius, right? And here it says you're raising the temperature from one temperature to another. So obviously we're going to be taking the difference of that temperature. So this equation actually is calculate the calories. So say calories is going to equal, it's going to be M cat, M cat, M delta T. Okay, So where M is the mass, C represents the heat capacity, the specific heat capacity, and T is the change in temperature. Okay, so if we're going from 25 to 175, so you have 175 is your final temperature, you have minus 25. Let's put our units so you guys can see. So that's Celsius. Our specific heat is 0.0308, and that's this over. So I have room. And that's going to be cals per gram Celsius. And this is actually, it'll say Q is actually what we use for the symbol for calories. It's energy, essentially. So instead of saying calories, I should say Q. And then we multiply it by the mass. What is the mass? It's 150. If we look at those units, this is the point that I want to point out to you. Look at the units. Grams are going to cancel out. Celsius are going to cancel out. And then you're left with just calories. Okay, what did you guys get? 693. Okay. You guys see how that works? Okay, so from 30 to 38, we get to say chemical change or physical change. Water evaporating. Physical change. So we'll put a P there. We'll put a P or a C. Okay. Silver, tarnishing. Tarnishing, it's kind of like the equivalent of rust for silver. It's chemical. Cutting the grass. Rusting. I'm sorry, a nail rusting. Baking a cake. Placing photos into a scrapbook. Formation of green leaves on plants. Did my look give it away? So think about it, because you're making the things that make the green leaves. So that's a chemical reaction. Burning leaves. Ice melting. Okay. Not too bad. There's only one that you guys are kind of like, well, one, and then you guys know what tarnishing was. So. Chapter 3. You guys ready? Atoms and elements. So which of the following elements is a metal? A, nitrogen. B, fluorine. C, argon. D, strontium. E, phosphorus. Anybody say A? No A, no B, no C, no D. You guys think it's D? Yeah, no, maybe. Yeah. Correct answer is D. Okay. So, which of the following is a noble gas? A, oxygen. B, chlorine. C, bromine. D, argon. E, nitrogen. Argon, that is correct. D is correct. Yeah, there will be a periodic table provided. So you have a copy of what it looks like. Okay. Yeah. You have one in your back? Oh, it's very basic. They just draw the line where the metals are at. And all you guys have got to remember, on the left-hand side of the periodic table is what? On the left-hand side. So if we look at it like this, okay, left-hand side, this side here is going to be what? And then this side is going to be what? Not metals. See? You guys got it, right? It's the line. It's right next to the line. Right? So use silica. Silica is a metalloid, right? Silicone is a metalloid. If you use that and you see where the line is and you see where the silicone is at, it's on this side of the line. It's funny because I've seen two different periodic tables. One will draw it where they separate the metals and the metalloid, and then the other side they'll draw it where the metalloid is on the opposite side. So I've seen it draw it both ways, but I always use silicone. Silicone is always what I use to distinguish. Yeah. So those are like little cheap methods, I guess. That's how I remember stuff. Or I'll take a look at another question on the exam and then use that to help me answer another question, right? Okay, so which is the element? So, sorry, the element in the element in this list with the chemical properties similar to magnesium is A. You said D. You didn't even let me finish the question. The correct answer is D. So we know it isn't sodium because sodium is a group 1 metal. We know that strontium is a group 2 metal. Okay. You're like, man, I wish all my questions were like this. Which of the following describes a subatomic particle? Sorry, which of the following descriptions of a subatomic particle is correct? A proton has a positive charge and a mass of approximately 1 AMU. B, an electron has a negative charge and a mass of approximately 1 AMU. C, an neutron has no charge and its mass is negligible. D, a proton has a positive charge and its mass is negligible. E, a neutron has a positive charge and a mass of approximately 1 AMU. So we're looking for the one that is correct. Atomic mass units. Yeah. So the correct answer is, we know that protons are they positive or negative? Positive. So we know we can get rid of, okay, well, we can get rid of this one because we know that one's wrong, right? So, and we know that neutrons are positive or negative, or neutral. They're neutral, no charge, right? So then that could be possibly right. But we know that the mass of the element is dependent on the neutrons, right? Because that causes us to have, so we know that's wrong. Okay. And we know that the protons also contribute because it's neutrons plus protons that add up to the mass, right? So we know that this one is wrong. And we know that an electron is negatively charged. And we know that I told you that electron weighs like a speck of dust, right? So it's negligible. So the correct answer is A. So when in doubt, start eliminating things. Right? The mass of an atom can be calculated from A, the number of electrons, B, the number of protons, plus the number of neutrons, C, the number of protons, D, the number of electrons plus protons, E, the number of neutrons. Was it? B. Right? So this is one of those cases where you use the question to help you answer. Okay. The correct symbol for an isotope of potassium with 22 neutrons is so first off, what is the symbol for potassium? Okay, so we know so we can get rid of a couple of things, right? So we know that this one is wrong, this one is wrong. Okay, so that gives us 3. So what goes on top? Is that going to be the mass or the atomic number? What is the atomic number? So 19 is our atomic number for potassium. Okay, so the atomic number is 19, so that we know that that should be at the bottom, right? So we can get rid of this. Okay, and the mass, or I should say, if we added 22 neutrons to 19, does that equal 41? Yeah. So then we know that this one is wrong. So the correct answer is A. A. You guys are saying, when are we going to get to the hard questions, right? These are a piece of cake. Dr. Henry's exams are harder than this. So which of the following gives the correct number of protons, neutrons, and electrons in a neutral atom of 118 SN 50? You said C. Okay, so this here's the number of what? Number of protons. It's also going to be, if it's a neutral atom, it's going to be the number of what as well? Number of electrons. Oh, okay, so that's good right there. And then the number of neutrons would be the difference between the mass number and the atomic number. So then that is 68. So we have 68 neutrons. So the correct answer is C. Okay, isotopes are atoms of the same element that have a different atomic number, B, the same atomic number but different number of protons, C, the same atomic number but different number of electrons, D, the same atomic number but different number of neutrons, or E, the same atomic number but different number, the same atomic mass but different number of protons. You said D as in donkey? Or did you guys say B as in bow wow? Or D as in, D as in donkey? You said D? Are you sure? D is the correct answer. Okay, 47. A sample of chlorine has 2 naturally occurring isotopes. The isotope Cl-35, mass 35.0 AMU, makes up 75.8% of the sample. The isotope Cl-37 has a mass equal to 37.08. makes up 24.3% of the sample weight. What is the average atomic mass for chlorine? How do we go about doing that? What was that? You said B as in boy, D as in dog. You said you went for A? Okay, so we have A and D. Those are our choices. So the way we would calculate that is we take that mass, 35, multiply it by the decimal version of this, which is 0.758. Then we're going to add 37 times 24.3. I'm sorry, point. Thank you. The decimal version of our percentage. Okay, what did you guys get? Three sig figs. What's that? It is D. She's like, I knew it anyway. So the correct answer is D as in dog. You rounded too much. Yeah, but you want to avoid those simple mistakes, right? Because they add up real quick. Okay, a sample of silicone has three naturally occurring isotopes. Si-28, mass equals 28.0 AMU. Si-29, the mass equals 29.0 AMU. And an Si of 30, mass equals 30 AMU. So if the average atomic mass of silicon is 28.1, which isotope is the most abundant? I like this question. You don't even have to do the calculations. You can kind of look at it. So this says it's 28.1, right? So is it closer to 28 or is it closer to 30? It's closer to 28. So who do you think is going to be the most abundant? Take a guess. A, B, or C. Okay. A is the correct answer. Right? So you can just take a look at it and see the number by looking at that number. Since this guy's really close to 28, 28 has to be most abundant. If it's close to 29, then that means 29 was the most abundant. Technically, there's a way that it could work out that you have a lot of 30 and a lot of 28, and then that could go too. But and then if it was 30, if it's closer to 30, then you know that 30 is most abundant. So, but by looking at the ends, you can kind of. Okay, the number of elements in the outer energy level of a neutral atom of boron, atomic number 5 is. Did you say 3? Good job. Yes, that is correct. So, what is the electron configuration for potassium, atomic number 19? Yes. No, it was 3 because it says the outer level, right? So the outer level, the first level would be, it would be period 1. Second level would be period 3. Period 2. If you count the number of electrons, 1, 2, 3, there's 3 electrons that would be to get to boron. Count over to boron, 3 spots, right? So that would be your outer level. Okay, so a quick way of determining it is this is the atomic number. We know that the atomic number is the number of protons, and it has to also be the number of electrons. So if we count these numbers here, it has to add up to 19. That's one quick way. So we can eliminate some things if it doesn't add up to 19, right? Does any of these not add up to 19? So that's 10. The first one doesn't. Okay, so that's 10. That's up to 19. Yeah. What about the second one? Well, I guess that one does too. Okay, that one does too. Oh, is that? Yeah, they must have known my tricks. Change the test since I took them. So 10, that's 19. Okay, so the next way is we know that S can only have 2 electrons, P can only have 6 electrons max, D can have 10 max, and F can have 14. Okay, so we know that P can't have 7. This says it has 7, so we know that that's incorrect. So this one is okay. What about this one? P has 8, so we know that this one is wrong, right? What about, it's okay. What was that? It has a 3s. So you said it has a 3s, but it's only 2. What do you mean? So if you look where potassium is at, right? So potassium, do you guys have your periodic table available? So I'm at the cheat. I'm looking for periodic table. So we know that potassium is here, right? So that means first and second. Okay, so we know that that can't be. So it's either this guy, this guy, this guy. Take a look at what's going on, right? So we know that potassium is a good form metal, right? So that means that it definitely has to have an S1, right? So this guy doesn't have an S1, right? So then we can get rid of that. Let me pull up the periodic table. No, I can pull it up so that they can see what I'm talking about. P, no, it doesn't always have to have 6. It could have up to 6. It can't be more than 6. Yeah. Yeah, it has to be up to 6. Yeah, if it's all the way up, yes. So let me pull up my table real quick. Okay, so now we're talking about potassium. First off, it goes to the 4th energy level. So if it doesn't go to the 4th energy level, then that's a problem, right? Because we know that it's at least 4s. So if we write down the electron configuration for potassium, it's 1s2. So 1s2, that would account for this guy, right? And then we have 2s2, that accounts for that 2nd energy level right here. Then 2p6, sorry to write my p. Okay, so then that counts for all of these. 3, 4, 5, 6. 3s2. Three p6. and then 4s1. And then that accounts for where we're at. Okay, so if we go to our choices, have all that right on there. Okay, so we know that this guy can't be right because it doesn't have a 4s1, right? Which it's supposed to have. So that one can't be right. So these are our options. So we want 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. This one says 1s2, 2s2, 2p6, 3s. Oh, right here, that's a 5. It's not enough, right? So we know that that's wrong. So D is the correct answer. And there'll be like, I think there's 3 questions like this on my exam that go with electron configuration. One is kind of like that. We did that, the outer realm. Oh, and let me show you guys. Did you guys understand that? Go. Okay. So a number of dots in the electron dot structure, or we often will call it the Lewis dot structure, of carbon is 4. Because we know that carbon has, oops, I wrote 3. Carbon has 4 valence electrons. So we have 1, 2, 3, 4. Right. You guys remember that? Yeah, if you count where carbon's at in that outer realm, 1, 2, 3, 4, you're not going to count the D, right? So, why are you making that face? I said, why are you making that face? The face you just made. Okay. So just a reminder. 1, 2, 3, 4. So when we're counting valence electrons, we're only counting S and the P. We don't worry about the D. Okay. Can you do me a favor and also send this to Parnell? Okay, so this should be a piece of cake now. Right? This is our classifications. So classify the following elements with options A through F. A noble gas. Any of those a noble gas? Argon. Alkali metal. Alkali. Group 1 metals, always a strong. So that's B. Anything else? Okay. Non-metal. Bromide is a non-metal. So that would be C. Anything else? C. Alkaline earth metal. That's a group 2 metal. Okay. That's D. Transitional metal. What was that? Copper. Okay. So that's E. And a halogen. So that one has 2 answers, right? Piece of cake? Okay. Oh, and actually, if we say non-metals, argon is also a non-metal, right? Questions? No questions? Okay. Nuclear chemistry. We didn't go over this, so I'm going to skip it. Actually, you should be able to get this. First one. So what is the nuclear symbol for the radioactive isotope of copper with a mass of 60? Mass number 60. What was that? Are you sure? That's 60 at the top? There's two of them. So we know it can't be this one. We know it can't be this one. There's D and there's A. What was that? So what is the mass? What is the atomic number for copper? Was it 29? So then the correct answer is A. But I wanted you to make sure that you're right. The nuclear symbol for helium, 4He2, is also the symbol for designating an blank, proton, neutron, gamma ray, beta particle, or alpha particle. See, gamma ray. Okay, so let me help you out a little bit here. So alpha ray is going to be a positively charged particle, right? And a beta particle is going to be, let's see, alpha is positive, beta is, I want to say it's negative, but it is up to. So it's either the gamma ray or it's going to be a D. I believe it's D, but I'll look for sure. So again, we didn't talk about this. You're not going to be responsible for it. So the symbol 0, E minus 1 is the symbol used for proton, neutron, gamma, beta, or alpha. I told you alpha is going to be a positive. So then beta is going to be, beta. So then gamma has to be right for the one above. I'm not gonna hold this for you guys because we haven't gone over it. It's not there, so we're not going to talk about that. Let's skip over this. This. Okay, but bonds. It's weird that they do nuclear energy before bonds. Okay, how many electrons will aluminum gain or lose when it forms an ion? How many electrons will aluminum gain or lose when it forms an ion? It's going to lose 3 electrons. You guys agree? And that's plus 3 charge. So it loses 3 electrons. Okay. What is the symbol for the ion with 19 protons and 18 electrons? What was that? Potassium plus. You know, the atomic number for potassium is 19. And then if we lose 1 electron, it's going to make it a plus. Okay. The correct formula for a compound formed with elements aluminum and oxygen is AL. So E is the correct answer. You guys remember how to figure that one out? What is the charge on aluminum? Aluminum has a +3 charge. What is the charge on oxygen? -2. So we know that we'll need, for these guys to balance out completely, we'll need 2 aluminum and 3 oxygens. So that's 2, 4, 6 negative charges. That's 6 positive charges. So our chemical formula is going to be Al2O3. The name of this compound would be what? Aluminum oxide. Okay. The compound MgCl2 is named A, magnesium chlorine, magnesium dichloride, magnesium 2 chloride, magnesium chloride, dimagnesium chloride. So we know that this is an ionic compound. In ionic compounds, we never use what? We never use the di, so we can get rid of this guy. We can get rid of this guy, okay? So we don't need to put the charge because we know it's a group 2 metal. Group 2 metals are always going to be a +2 charge, so we don't need to put the, okay? So then it's either A or D. D is the correct answer because we know that when it's an ion, we use chloride, right? So it's not A. '71. F. I didn't even get a chance. Fe2 parentheses SO4 parentheses 3 is called C, iron 3 sulfate. That is correct. There we know that it's going to be iron 3 because we have, well, we know sulfate has a -2 charge. So we have 3 of those. Okay, so then that would be -6. So that means, and there's 2 of these, so then that means that each one of those have to be a 3. Okay. So which of the following elements does not exist in as a diatomic, does not exist as a diatomic element? Who are your diatomics? Have no fear of ice cold beer. Have hydrogen, no nitrogen, fear fluorine, of oxygen, ice, iodine, coal, chlorine, and beer, bromine. Okay, so then which one of these aren't any of those? Carbon. So choose the best electron dot structure for OCl2. Oh, interesting. You said E? Okay. Yeah, that would be the best, although it's wrong. So but that would be the best of your choices. So why would it be wrong? Who likes to be in the middle? It should be the one that has the least electronegative. We know that chlorine is electronegative than carbon. Chlorine is less electronegative than oxygen. Oxygen has a stronger electronegativity than chlorine. So the chlorine actually would be in the middle in this case. But of the choices that were given to you, that would be your best choice. And then also, chlorine also likes to have those single bonds. Doesn't like to form double bonds. Okay, so what would be the correct name of that compound? Is that nitrogen trichloride? Okay. So since this is a covalently bonded compound, we know that we use the prefixes here. Okay, which of the following substances contain a non-polar covalent bond? Non-polar covalent bond. What does non-polar mean? How are you sharing? Evenly or unevenly? It would be even sharing. Okay, so who's going to be sharing evenly? Well, let's get rid of what we can get rid of. We know that sodium NaCl, that's an ionic bond, right? And we know that magnesium fluoride is an ionic bond. So then we have these three choices. Now, if you have two of them that are exactly the same, is one going to be pulling more than the other? No. So then we know that correct answer is makes it easy, right? Okay. We'll try to wrap up. And then anything that we don't finish, Israel said he'll go over, right? On Tuesday. So which of the following compound contains a polar covalent bond? Okay, which ones can we get rid of? Okay, we can get rid of this one. We can get rid of this one. Now, which ones can we get rid of these? They're exactly the same, so we know that those are going to be non-polar. So then the correct answer is B. As long as it doesn't say AQ. So which of the following compound contains an ionic bond? So which ones can we get rid of? Okay, because those are all non-metals. H2, anything else? CH4, anything else? Okay, so this is the only one that has a metal and a non-metal. Okay, 78. If the electronegative, if the electronegativity difference between X and Y is 2.1, the bond between X and Y is A, ionic, B, nonpolar ionic, C, nonpolar covalent, D, polar covalent, E, impossible. Nope. 2.1. Yes, remember the scale? If it's less than 0.5, it's if it's less than 0.5, it's not ionic. No. Oh, you said the answer is ionic. That is correct. The answer is ionic. So if it's greater than 1.8, it's going to be an ionic. It's going to have ionic character. So this is BS right here. So we got rid of that. You know that impossible is BS. And then the other ones, this guy would be less than 0.5. This guy would be between 0.5 and 1.8. Okay, shapes. We'll stop at 80. Now we'll only leave 20 left. So the shape of ammonia, the ammonia molecule is A, linear, B, a square, C, pyramidal, D, hexagonal, E, octagonal. The shape of carbon dioxide is A, linear, B, a square, C, pyramidal, D, octagonal, E, bent. It is linear. That is correct. When we know that Lewis dot structures, we know that this guy is going to look like this. H, 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 2 electrons. Top, and then this guy is going to look like this. C double bond O. C double bond O. Lewis dot structures. Was that helpful? Yeah. Piece of cake, right? Not too bad.